What is up? We are so back. We are so back. We're so back. Welcome to the first RIT-Sec meeting of this semester, week 13 for us. Clap it up. Let's go. We are so back. Let me tell you something. We're so back. Okay, we're going to get started. I'm so excited right now. Oh, my goodness. All right, announcements. Oh. Join the Discord. I know there's a lot of new people here. I would like you to join the Discord. I'll give you a second to scan the QR code. Hello. We good? We're gaming? All right. You need to join the Discord server so that you can sign in. All right. You know the vibes. Is it signing up? We're good? We're good? Okay. Please sign in. I'll give you a second. We are so back. Okay, please get a second. Okay, it's up. Please sign in. You have to sign in to get pizza, by the way, for new people who didn't know that. We will check. Okay. Also, check the calendar. Join the calendar. That's how you're aware of when everything's happening, like our interest groups and our weekly meetings and all our other fun stuff to be planned throughout the week. Please check it. Here's the QR code for that. I'll give you a second to scan that, you know. Okay, we're so back. Okay. Mr. Brad has a word.
All right, hello everyone. I know not everyone's here in this room today. Some of you are on Twitch, but everyone will see this announcement because I just sent it in Discord. So we on the e-board have been working over the past few months to really focus on how we can scale this club beyond what we currently are. Sorry, I'm just trying to remove all those embeds so it's not annoying. We're working on trying to make this club scalable. So we've been going through the Constitution, the way we structure our club, and yes, if you didn't know, we do have a Constitution. That's roughly how we run our club, how we structure our club, how our IT-Sec works. And we've noticed, some issues with that. We've noticed some issues we'll hit with scale. So we've been working to revise that. Some of the highlights of these changes, we used to have something called independent programs as well as our interest groups. We've now removed those and merged those into one singular thing called an interest group. No IGIP, it's just IG. Keep it simple. We've formalized the definition of interest groups as well as their proposal process. So every interest group now is officially defined in the Constitution. When it's proposed, it gets written into the Constitution. That way, the original intent of the interest group cannot get misconstrued over the years. So yeah, the way this works is we will give you guys 1 week to review the Constitution. If none of you wish to propose a full veto, which I will go through that process, then we're good to go, and the Constitution will get ratified and merged in. If you do see issues where you have questions, comments, concerns, requests for modifications, etc., please reach out to eBoard, specifically myself or Max. That's the best way to get it. If you would like us to modify it, we can take in your modifications. If we like them, we will, modify them and repropose this next week. If you wish to propose a full veto of this change, you have to come to us. It's detailed in this announcement, but please just provide a summary of your reasoning for the full veto. We will, talk about it on eBoard, make sure it's not just, an out-of-pocket request. If it's valid, which more than likely it will be, we will hold a public vote during the next meeting. 3/4 majority will veto the change to the Constitution. Is that cool with everyone? Anyone have any questions for me? No? Cool. That's great. Mr. Kenny, keep going.
Okay, I'm back. Okay. Oh, goodness gracious. Okay. We now have a new demo and education survey that I would greatly appreciate. Well, me and Alex would greatly appreciate you guys taking the time to fill out. So we're going to be giving out a new survey each week to help make this entire education/demo section of our weekly meetings a lot better. I know that some of you have comments and concerns, and we gladly accept those. And am I not? Oh, goodness gracious, I'm sorry. Yeah, we kindly accept those because we're always trying to get better. We would like you to fill it out regardless if you do the demos or not, and you get demo points when you do it. 50 points, that's a lot of points. Okay. Do the survey, please. Interest groups. Did you want to do this one? No? Yeah. Okay.
All right, so this is a quick highlight of all our interest groups, not independent programs anymore, all interest groups. Obviously, next week we'll see if that passes. This is all of their updated meeting times, right? None of these have changed since like Thursday and today, right? IG leaders, cool. All right, so these are all the overview of their meeting times. Yes, we will get them updated on the website. Sorry, they're probably a little bit out of date. So we have all of these different interest groups. Is there anybody in the room who was not here last semester? Do I need to go through these? Don't be afraid. Don't be afraid. It's okay. It's okay. All right. So I'll give you a quick highlight. All right. So our physical security, you can learn lock picking, physical security bypasses. So that is like doorways, physical access controls, such as like card readers, RFID, etc. They go into that kind of stuff. Mr. Bailey Powers over there, Mondays 4 to 5. Ops interest group, if you're interested in helping run our infrastructure and learning how to do that, kind of sysadmin, networking, server administration, all that kind of stuff. Mr. Malik, right there, our ops lead, he runs that. That does lead into our ops program where you will actually help run our infrastructure. So join that if you don't know a lot right now. We'll teach you and then obviously help you get into the ops program. If you do have experience and want to get into the ops program, Malik is releasing signups for that. RVAPT, they do pen testing. Is Smash in here? No. Okay, Smash is not in here, but Smash runs that. They do pen testing, a lot of hack the box, learning about actually like reporting and the whole pen test process. So it's not just actually pen testing a box. You learn about the whole process. You can learn to be a pen test consultant. Team Contagion, they do CTFs. They help make CTFs. They compete in CTFs. They represent RITSec up all the way up to a national level. Yeah, that's great stuff. Is Chandy in here? I thought I saw him. No. Okay, I know I didn't see Tenchi. Okay, sorry, some of these people are missing, but these are the people, usually their names match on Discord, so if you have questions, feel free to reach out to them. Wireless, anything RF, wireless, so Wi-Fi, just standard radio, Bluetooth, etc. All the like. Mr. Kenny, Brayden, right there. Impressive duo. WESIS, is Ashley in here? No, okay. WESIS, Women in Cybersecurity, it's not just for women. They do tons of great stuff. Right now, they're preparing to go to the WESIS conference. So if you're interested in attending / already applied, right? Is that deadline close? Okay, if you've applied, check your emails. But if you haven't and you haven't attended WESIS and you're kind of interested, they have tons of great talks from industry people every single week. Kind of like a little mini RITSec. It's great. I go to all their meetings except for the first one I didn't make it to. Sorry, Ashley. But reverse engineering, that's great. Sharad, are you in here? Did I miss you? No. Oh my gosh, how are we missing every single person? That's so sad. Okay, so reverse engineering, learn about reversing, so you'll work with things like IDA, you'll learn assembly, you'll learn how, programs actually get executed on computers so you can start to reverse engineer malware and other software. Really cool, really fascinating stuff. If you like problem solving and like puzzles, great place for you. Red Team Recruiting, Mr. Mav right there. I don't think Jason's here, but Mr. Mav, if you want to learn how to be on the RITSec Red Team, come to our Red Team Recruiting. Great time. We'll teach you how to develop your own Red Team tools. Did I miss anyone on this slide? Okay. I think we got everyone. Just wanted to make sure we covered all of them. Red Team Recruiting, by the way, does lead into the RITSec Red Team. So we will work with you to develop your own tool. Once you develop your own tool, we can, chat about actually moving on to the RITSec Red Team. talk to Matt for more information.
And that's just a I can't speak. Visualization of when all the interest groups, interest groups meet. You can also get that by joining the calendar that I had put up earlier. You guys should do that. I'm looking at you, Chase K. All right. Meet the sponsors. Clap it up. Let's go. Come on. You know. We would not be able to do any of this without them. So, yes, keep clapping. All right. Follow our social media. Sophia's doing a great job over there, and I would really appreciate it if you guys did that. You get to see some nice pictures and posts. Oh, yeah. Social media's been popping lately. Okay. So, for this week, we'll be having cloud computing with Mr. Brad Harker. Thank you. Everybody please clap for Brad.
All right, let's see. Kenny doesn't have the speaker notes up. I'm so sad. Am I the only one that uses speaker notes? Does anyone else in here use speaker notes? I see some hands. If you aren't using speaker notes, you should use them. They're kind of great. You don't want to see anyone like holding note cards up here or something like that. That's kind of lame. Look at that. Triple laptop. Let's go. All right. So cloud computing. Who in here, just raise your hand first off the bat. If you think you know what this term means, raise your hand. Cloud computing. You think you know? Cloud. When I say cloud, what do I mean? What do I mean? Servers on the cloud that you can deploy stuff on. Where is the cloud? What is the cloud? Anyone know? Oh. Someone else's computer. That's pretty good. That's a pretty good generalization. That's usually how I explain to people. We're all just sharing computers. So in this talk, we're going to talk about a few fundamental questions. We're going to take it back to basics. Sorry, this does not have the windscreen on it. Does this come off? Hold on one second. Hello? Whoa, that's so much better. Okay, perfect. Okay. Oh, that's so much better. Okay, we are so back. All right, so we're going to take it back to basics. Sorry, I had to take a little break. Switch mics. It's okay. Technical difficulties. So we're going to take it back to basics. What is a computer? Does anyone know what a computer is? What is a computer? I don't know. We're going to answer that question. And also, how do we share computers? I know when I was little, my brother and I, the way we shared computers was beating each other and seeing who got to it first. But I don't know about you guys. So let's start with the first question. What is a computer? So obviously we head to the old Wikipedia, most reliable source on the internet. We get this big fancy quote: computer is a machine that can be programmed to carry out sequences of arithmetic or logical operations, computation, automatically. Too fancy for me. Really? What a computer is, okay, ready for this? It's really just a rock we tricked into thinking, okay? I took so much time to make this big fancy graphic, all to demonstrate that it's really just a rock we tricked into thinking. Doesn't really matter. My notes say hold for laugh. You guys are supposed to hold for laugh. That's okay. It's okay. So here's another question. We're getting a little philosophical. Does a computer know it's a computer? Think about that one. Scratch your heads a little bit. Do a little chin scratch. I don't know. That might be a little too philosophical. But right now, let's go under the assumption, a computer's pretty smart. It probably knows what itself is. We as humans, we know what a human is. Computers probably know what a computer is. Here's another question. Can a computer simulate a computer? So if we can program a computer, we can make it do stuff. and we know how computers work. Can we make a computer simulate another computer? Who thinks yes? Raise your hand. Sorry, people online, you probably won't see all the hands raised, but I'll tell you, the majority of the room raise their hands. So if we can make a computer simulate a computer, what would we actually call this kind of simulated computer? Maybe we call it a virtual computer. Sound about right? Virtual computer. That sounds pretty good to me. I don't know, pretty industry standard. But let's, we can adjust our language a little bit, get a little more technical. Yeah, let's call it a virtual machine, okay? Virtual machine, because it's a machine. It can do some computation, okay? But yeah, so a computer simulating another computer, we're going to call that a virtual machine. And we'll start with that assumption. Sorry we had to take it all the way back from a rock to virtual machine, but we got to make sure our fundamentals are right. But yeah, we could get way more in the weeds about what a virtual machine is, but let's keep it high level. Virtual machine, computer, simulating another computer. All right, so back to our two questions. What is a computer? A rock we tricked into thinking, right, everyone? Anyone asks you what a computer is, that's the answer you give them. I promise you it'll go over wonderful, especially in an interview. So how do we share these computers? That's our next question that we have to answer. So my wonderful graphics, you'll love to appreciate these throughout the presentation. So we have a computer, and we have Bob and Alice, the classic duo. Sorry, these are just default pictures. Whoa, there's a lot going on outside. These are just default pictures I found on Google Images, but it's okay. But let's say Bob and Alice want to share a computer, and maybe it's in like a public library or something. It looks like it has a really updated operating system. You got a landline next to it. Ooh, portable DVD player. Ooh. Is there anyone in here who's never used a DVD? You've never used a DVD? Oh, wow. Okay. All right. Well, this is going to be rough. All right, so let's talk about different models of ways we can allow Bob and Alice to share this computer. So the first model, the way my brother and I would do it, whoever gets to it first can use it. But as you can see, Alice is really, really angry and grumpy about that. As you can see by her angry eyebrows and frowny face, that is totally hers. But Alice gets very angry over this. So, what can we do to prevent, unfairness? Well, we can add a timer. We can add a timer to Bob. So let's say each person only gets to spend 5 minutes at the computer. Sometimes my parents would have to do that with my brother and I. This makes Alice feel a little bit better. It's a little more fair. Each person gets to spend 5 minutes, but she only gets to spend 5 minutes on the computer. Who wants to spend 5 minutes on the computer, okay? Some YouTube videos are like 20 minutes long, bro. Come on. I want to watch, I don't know, Mr. Beast or something. What do people watch these now? I don't know. Oh, I'm dating myself. So, let's try and, make the sharing model a little more equal. So let's take the computer. We add this big fancy conveyor belt on the front of it, okay? I promise this is how it works in real life. Just slap a conveyor belt on your computer, set up everyone who wants to use the computer right in front of it. So in this model, each person's going to get a piece of paper, and they get to write down, what do you want the computer to do, okay? Bob's going to browse the google.com. Alice wants to play Pop Tropica, okay? Who in here played Pop Tropica? Raise your hand. That makes me real happy. I'm glad everyone gets that reference. I was going to be so sad if people in here didn't play Pop Tropica. Online, if you played Pop Tropica, you can put it in the chat. Also, what did we get in the chat? Can someone delete this? I don't know. We have bots in the chat, okay? Please do not click anything in the Twitch chat right now. So the computer's going to run these instructions as they come in. It's going to first, since Bob submitted his instructions first, it's going to browse google.com, and then Alice is, the computer's going to play Pop Tropica. That's no fun. Alice doesn't even get to play it. But what does this look like kind of in reality? A little bit. Let's get a little more realistic. So let's take a really, really big computer on the left. I promise you this is probably a common sight more than you think. Of course, we have to give it a real good name with absolutely no underlying meaning whatsoever. You know, us and sysadmin, we like to make up names. No meaning whatsoever, I promise you. So let's use this big computer, and now let's simulate 2 virtual machines, okay? We understand the computers can simulate computers. Let's simulate 2. So now, Bob and Alice can each use their virtual computers at the same time, and no one has to wait for anything, because this computer has the power to simulate 2 computers. So let's get even more real. Okay, there we go. So let's get a little more realistic. What does this actually look like in practice? So this is what we call distributed computing. And that's what we use to describe like standard cloud computing today. This is what we call it, distributed computing. But what does that really mean? So distributed computing really is just multiple computers that are working together. And to the outside world, all of these computers appear as a single computer. So you know that really big, messy computer that we just by chance named US East 1? Well, in reality, that's not just one computer. That's a lot of computers that we can then simulate other computers on top of. So this allows more resources than we can actually physically fit in a single computer, because there are limitations. So we use multiple computers, speed up the whole process. So there's some advantages. Scalability, you can grow the system. Let's say you need more resources, you can just slap some more computers in there. It's all right, Malik knows about that. Just slap a few more computers in there. It'll be all right. See, he knows, he agrees. Availability, so we can tolerate if just like one computer, Malik probably also knows about this, one computer going offline in our computers. We can tolerate that as long as only one of 20 goes offline. We'll be all right. Consistency, so we have all of the data being duplicated across all these computers. That way, all the computers are on the same page. We don't have one computer saying we have $5,000 in our bank account, and the other computer saying we have 0. Even though we wish it was 5,000, it probably actually is 0. So all the data is consistent. Transparency, all the physical devices, like I said, they appear as one giant computer. So we don't have to worry about, oh, why did Amazon's 1,287th computer go offline? Now we don't have to worry about that. They all look the same. They all appear as one. And then efficiency. Obviously, it's super efficient because we can use resources. Maybe different computers have different types of resources. Maybe this computer has a graphics card in it. Someone needs a graphics card. Well, we can sort all the graphics processes to this group of computers. So we can shift it around, make it super efficient to run on our computers and optimize that. So there's a few real technical models. I'm sorry we're getting more technical now that we went from the fancy little pictures from Google Images. But so there's some different concepts in distributed computing. And so top are concepts, bottoms are models. So the 2 concepts I want to cover are loosely coupled and tightly coupled computing. So I promise you these are industry standard. These come straight off the AWS website, I think. So loosely coupled, I can take out a computer and it won't really affect the whole model. So think client server. If I have a web server, I take the client away from the web server, it's not going to just break the web server, right? Obviously, we don't need to be 100% connected to a web server all the time. These are loosely coupled. They can go in and out of connection. It's okay. As well as tightly coupled. So this is when we have what RITSec hosts, a tightly coupled cluster. That's another word I'll be using, some verbiage I'll be using throughout the talk. Cluster, just a small group of computers. But this is a really fast local network for connecting computers that are all performing the same task. So they can have high-speed communication across all of them. 2 of the common models that we have are parallel computing, where every computer is just a processor, and we share all the memory. So you know how your computer, when you go boot up Minecraft and you give it some extra RAM, right? Well, instead, think about if I could have all 3 of these computers running Minecraft, but they all share the same RAM, so they're all playing the same instance of Minecraft, okay? Sorry, I don't know why that's the first thing that came to mind when I thought about RAM. But so this is a tightly coupled system, right? Obviously, if we're dedicating some CPU resources on this computer and this computer dies, well, that process is just completely gone, and the other 2 are wait, what happened? And since they're all sharing the same RAM, I mean, that data is just going to sit there because this is no longer crunching the numbers. But yeah, so they don't need to share data between each other, which is what makes it super fast because they already share all the same memory. And to be fair, memory could also be not just RAM, but like SSDs or something like that. We also have something called grid computing, and this is really common at super large scale. So this is pods of tightly coupled systems that coordinate together. So let's say I have 50 compute clusters. Those clusters are all parallel compute clusters, but then I connect them all in a giant loosely coupled system. This is like scaling even larger. We're talking about grid computing at this point. So back to what I asked you at the very beginning, the cloud. You know, you hear this big old term, the cloud. I'm probably going to be using this presentation or word a lot during this presentation, but you know, I think we answered that pretty much already. Did someone actually tell me what the cloud was? Does anyone want to tell me right now, what do you think the cloud is, the cloud? No one's brave enough? Someone else's computer? Mr. Kenny says someone else's computer. Okay. Well, first of all, this is a cloud. I don't know if it's the cloud, but I can definitely tell you that this is a cloud. But this is probably also a cloud. I don't know if it's the cloud, but this is definitely part of the cloud. So in practice, this is what the cloud really looks like. It's a massive data center full of servers. Unfortunately, this is a reality of today. Sorry to disappoint. It's not as great when you cloud watch this type of cloud. So let's get into like actually using the cloud. How do we access the cloud? So first off, we're probably going to need like a keyboard and mouse, probably a laptop, something like that. We're probably going to need a computer in the first place. It would probably be pretty helpful. Next, we're going to need to choose a cloud provider. So obviously there isn't just the cloud, there are multiple clouds. So some of the ones that I picked out that I like, AWS, Azure, GCP, Google Cloud, DigitalOcean, Heroku, and Linode. These are all services that I have used and I can personally vouch for. So if you have issues, you can blame me that I recommended you. But these are very common. Just these are ones that I've used. There are plenty of others out there. You can even make your own cloud if you want. Go to OpsIG if you want to learn about that. Sorry, this is like heavily like pointed towards OpsIG. But so let's talk about accessing the cloud. So first off, you're probably going to go to your cloud provider, and they're going to have some form of web interface. This is going to be extremely specific to your cloud provider. I'm trying to keep this talk as like high level as possible, so we're going to stay out of the weeds on how to actually navigate all these web interfaces. But during the demos, you will be navigating a web interface of a very specific cloud provider. So this could simply just be going to the web interface of your cloud provider. If you need to spin up a VM, if it's all automated, maybe you don't need to use more than the web interface. Pretty easy. This is pretty common. A lot of them use automation, so you pretty much will never need to do it. I know you can spin up, for example, a database on AWS. I never even need to actually SSH into a box. It just automatically sets everything up. I just go click a few buttons in the web interface. But for example, if we're spinning up a virtual machine and we do need like actual access to the simulated computer, well, there's some other methods. So first of all, we can use a console. So when I talk about a console, no, this is not like an Xbox or a PlayStation. This is things like VMware Remote Console. Maybe there's a web-based console, so something like you'll get in RLS or ESXi. These are two things that RET uses, just doing that so you guys are aware. But there's going to be a console. So this is usually going to give you a desktop or what it would look like if you were physically at if the computer was physical and you were looking at it like on a laptop. You can also do some remote command line stuff. So if you use something like SSH or WinRM, those are for Linux and, well, technically I think you can put SSH on Windows, but mainly for Linux and Windows for remote command line interaction with these virtual machines. If you want a desktop, if you have something that supports a desktop, maybe you're running a Windows VM, You can use something like NoVNC, Spice Console, or Windows RDP, something like that. There's plenty of them out there. I'm not going to be able to cover all of them. But you'll use a remote desktop software to be able to get something visual out of that. But by far, I think true and true, I could speak for everyone. The most common access method is going to be SSH. I know most people simulate Linux on the cloud, but there is, a lot of Windows out there too. So you're going to use like RDP for that. So SSH, RDP, probably your most common. So with the cloud, we know how to access it, but how do we authenticate to the cloud? How do we log in? I know it may be simple as going on your cloud provider, putting in a username, password, but beyond that, there is a lot of ways to prove who you are and get access to the cloud. Some of these methods, your first basic one, like I just described, you're going to go to your cloud provider, log in with username, password. Maybe if you're working at a company, you're going to have single sign-on set up, so similarly to how RIT does it. You're going to go log into like Google. Go log into Google, it's going to redirect you to RIT's single sign-on. So those are the super basic ways to get in. Maybe this integrates with your cloud infrastructure if your VMs support this, but maybe they don't. So another common way of authentication is cryptographic keys. And so these are used commonly in two different ways on cloud providers. So one is going to be a user-managed key. This is when you take a key generated by you and give it to your cloud provider saying, hey, this is my public key. So if you ever see information coming from me, you can use this to decrypt it. That's how you're going to authenticate me. There's also service keys. This is coming commonly with it, that I'm familiar with all the service keys of AWS. Other cloud providers also do this, not exactly familiar with any exact which exact ways they do. But these are cryptographic keys generated for internal use. So for an example, you can, in AWS, if you spin up what's called an S3 bucket, all of your data is going to be encrypted with a data encryption key, which is a service key. That way it's stored by AWS. No one else should, in theory, have access to it. And no data can come out unless it's decrypted with this key first. So some examples, you've probably seen these around. This is an RSA key. This used to be the industry standard. This is what the actual key looks like. So it's a private key. These are not my private keys, just to put a disclaimer. I looked up an example key. Not sure whose private key or if anyone actually is using this, but please don't use this. I'm putting it out on the internet right now. It's been out on the internet for, I think it was like a 2018 article. I'm not, please don't use this. Okay, if you understand nothing about cryptographic keys, don't use this. But this is what it looks like. You're gonna have a private public key pair. If you haven't taken cryptography and you're an RIT student here, you will learn about this. But what this means is that what you encrypt with one, you can only decrypt with the other. The verbiage, you keep this one private, you keep this one public. The new industry standard is going to be EDDSA or ED25519 keys. That's what they're called when you generate them with SSH keygen. But this is elliptic curve cryptography based, so they're a lot shorter, as you notice. They're a lot easier to work with. You don't have to have this massive key that you send around. It's real small when you send people your public key. But that's what that one looks like. Super small. It's now the industry standard. Now that we're moving it, especially into cloud computing, people can utilize thousands of VMs to try and crack RSA keys now. So I don't think it has been done, but theoretically it is possible to crack an RSA key, especially with the rise of quantum computing. There's a whole class on that here at RIT, post-quantum computing, or post-quantum cryptography. So yeah, they're way smaller, easier to use. So something that we have to talk about, and sorry it's a big scary term, federated identity management. Does anyone off the bat, before I actually explain it, know what this is without just sitting there interpreting the diagrams on the screen? Okay, well, it'll be familiar if you came to my cloud security talk from last semester. But the federated identity management is essentially allowing multiple providers, so in this instance we're talking about a cloud provider, to form what's called a trust relationship with whoever provides your identity, your identity provider. So think about RIT as an identity provider. They provide you with your account credentials, a way to authenticate. AWS will form a trust relationship with them. That way, when you're authenticated with RIT, AWS says you're good to go because RIT authenticated you and I trust RIT. So it's a lot of like kind of buzzwords, breaking it down. So if I know Alex right here, if you don't know Alex, you should know Alex. He's a pretty good, trustworthy guy. So if I know Alex right here, and Joe comes up to me and he says, "Hey, can I have $20?" I don't trust Joe. Sorry, Joe. Sorry, Joe. I don't trust Joe. Okay, like I don't know him. Okay, but I know Alex, and Alex says he knows Joe, and so I go up to Alex and I'm like, "Hey, you know Joe, right? Huh? Yeah. Oh, you don't know Joe? No, you know Joe. Okay, trust me. You know Jim. Jim knows you. Sorry, Matt gets it. But yeah, no. Alex knows Joe, and I go up to Alex and I'm like, "Hey, should I really give him $20?" He's like, "Yeah. He'll pay you back. It's okay. Trust me." So I'm like, all right, I trust Joe because I trust Alex and Alex trusts Joe. So it's this big chain of trust that gets, it can be like way more complex than this diagram gets it. Trust me, yes. This is a way simpler version. But essentially, when you're talking about single sign-on and that kind of stuff, this is all like a subset of federated identity management. Federated identity management, often you'll see it like FIM, is like a really big concept. Super great, especially if you want to get into what's called IAM, Identity and Access Management. That's big, especially in the financial industry. These kinds of concepts are super important. Okay, there we go. So now that we can use cloud computing, what are the risks associated with using cloud computing? This seems kind of dangerous. We're using someone else's computer that, in theory, anyone else in the world can also use. So we've decided on what cloud provider we're going to use, but everyone else can use that cloud provider too. So let's talk about a little bit about how do we secure cloud environments? How do we make sure that when we use someone else's computer, we can make sure it's only private to us? So the first step is you go watch these 2 YouTube videos by this really, really smart guy on the RITSec YouTube. No idea who this guy is, but he's like super smart, okay? Trust me. But yeah, you go watch these 2 YouTube videos. It's a 2-part series on cloud security. It'll go into some pretty deep detail. This guy uses AWS as an example, but these kinds of concepts go across all cloud providers. Yeah, but there we go. For real though. So high-level overview. We need to form some type of cloud security program. If you're at an enterprise and you're using cloud resources and you do not have a cloud security program, it can be as impromptu as a few of your security guys forming this small program. They need to focus on securing your cloud environments, even if it's only a subset of what they do. It's important to an organization so you can have dedicated people focusing on your cloud security posture. You're also going to need some form of policy and governance. There should only be one way to do it at your company, and that should be the secure way. You need to set some policy and governance procedures. Make sure that everyone, especially when you're talking about like engineering, R&D department, make sure they're all doing things the proper way. When someone comes up to you and says, "Hey, trust me, I need to stand up this VM, but it's only for like 5 minutes. It needs to have no firewall rules." All right? No, that's not how we do it around here. We use our secure base image, etc. So you need to set some policy and procedure, make sure everyone's doing it the correct way. Also, one thing I actually forgot to include here is auditing to make sure that people are doing it the correct way. So auditing is going through all your logs, making sure to catch any anomalies, which would be people not doing it your way. You're also going to need, like I said before, an IAM solution, Identity Access Management. You're going to need an IAM solution, whether that be for cloud alone or ideally integrating cloud into your FIM solution. You should probably also work with or be a part of your IAM department to integrate your cloud environment directly so they're aware of all the kinds of resources that people have access to. So This is actually taken from those 2 YouTube videos. Don't know how I got a copy of that really smart guy's slides. But this is a high-level overview of what I recommended. Oops, I said I. What I recommended for the cloud security programs. All of these are super important topics that need to be covered. Obviously, you guys can read, so I'm not going to read these off to you. But this is a high-level overview. It's a lot, but trust me, once you generate these or work with someone to develop these cloud security programs, it really runs itself. A lot of cloud is automated nowadays. But definitely go watch those YouTube videos so you have a better understanding of these topics. Another thing, and this is coming straight from our good friends, our alumni at AWS, they told me I should definitely talk about least privilege, principle of least privilege in the context of IAM. So does anyone in the room raise your hand, know what principle of least privilege is? Okay, I see a lot of hands like slowly going up. People are looking around like, oh, it's not just me. I'll raise my hand. Yeah. All right, right all the way in the back. What's the principle of least privilege? All right, that's good. That's good. Anyone want to build off of that? Kyle? Okay, so giving people as little privilege as they need and creating a system that, can you repeat the last half? Okay, so creating a system that allows people, can detect and allow people only certain access based upon their privileges. That's pretty good. That's all a part of it. So the principle of least privilege, really every user should only have the privileges to perform the task at hand, nothing further. If I'm creating these slides, I should only have access to these slides and nothing else. I should only have edit access. I can't modify slides that were not created by me, etc. Really strict access control. Obviously, if everyone followed the exact principle of least privilege, this would be the most secure world possible, okay? But in reality, it doesn't always get followed. The way you do this is each task that you're doing, you have to assign it a specific privilege level. And then each user should never, and goes into our auditing, each user should never exceed the privilege level of their highest task that they need to do. So if Alex is our tech lead and the highest ranking task that he needs to do is upload a challenge to CTFD and modify CTFD, he shouldn't be able to pivot beyond that. He shouldn't be able to go access RITSec social media accounts, for example. It's not within his role. So principle of least privilege, we need to limit the access that every user has to only what they need to do. Sorry, I almost sneezed there. I did take my allergy meds this morning, so we're gaming. So we need to talk about, I didn't switch this one. We need to talk about identity. So how do we manage identity within this principle of least privilege? A good way to do that, and by far this is not the only way, but my preferred way, we place users into groups. So if we have the ops program has a bunch of different teams. We have a cloud team, we have an infrastructure team, etc. We'll place all those users, all those members, into those specific groups, and each of those groups can only have specific access based upon what they're responsible for. Our infrastructure team is only going to have access to our infrastructure. Our cloud team only going to have access to our GCP, our Linode, etc. We're not going to allow our people who manage OpenStack to be able to go in GCP and modify stuff. Principle of least privilege, they're not allowed to go outside of their role. If they do, they have to use a separate account for that. One thing I just thought about that I didn't put in here is when you do have someone who has multiple roles. Wait, did I? Oh, I did. I'm smart. Okay, so here's the concept of roles, and I didn't exactly outline this, but every user needs to assume a role in order to do a specific task. So think about it like sudo. So some stuff on the Linux operating system is protected, and it needs a higher level of privilege. So you need to run sudo. So you assume a higher level of privilege. So by default, users should have no permissions, right? And they need to log in to a different account, super basic way to do roles. Just give them a different account for each role. Let's say I'm both a web administrator and a database administrator. One account should not be able to touch both. I should have one account that I log into that has permissions to edit the website. You log out, I log into a separate account to manage the database. They should have separate passwords, separate usernames, etc. That way we have this form of roles. So if one account gets breached, not everything gets compromised when you have that one IT guy who does everything. And then obviously go watch Cloud Security Part 1/2. That's that great guy. Shameless plugging, like this is what, the 4th time. But yeah, so that's the end of my presentation. We're keeping it super high level. I know cloud, I could get super in the weeds, but I want to keep it high level. If you want to get more in the weeds, go watch Cloud Security Part 1 and 2. I promise you that gets super technical. What is that, number 5, 6? Boom. Dude, I'm fucking on it. Okay, sorry, I'm cursing on stream. But so is there any questions from the audience before I go? Mr. Mav. Oh, so what do I like cloud and what are some of the advantages to cloud? So obviously it's really expensive to buy your own computers. I don't know if you've bought a computer lately, let alone a server, but hardware is super expensive. So, obviously I could go ask Kenny, hey, can I rent your server for like 2 months and go bring it to my apartment and set it up? No, super expensive. Cloud, it's super cheap. So I can go run like an AWS S3 bucket for, I don't know, a couple days, get like, a couple million file downloads. Cost me like $350. I don't know. It's super cheap to use public cloud infrastructure. That's because everyone is bearing the load of the cost of running this infrastructure. Because in reality, when I buy a server, like 128 gigs of RAM, like 32 CPU cores, I'm not going to use all that. Okay, so we share the load of the cost of actually running those servers. So it's super cheap, way cheaper than purchasing your own hardware. That's one reason I like it. Also, it allows you to manage it from anywhere without having to set this stuff up on your own. You can just like log into AWS from anywhere and go manage your stuff. Let's say I run a website on AWS. Boom, I can like log in real quick. Also, a lot of these cloud providers offer a lot of like VPN services, multiple access methods. So, it really allows for this scalability and anywhere access. But scalability is another reason. The fact that I can just go spin up 500 VMs and I don't have to worry about, am I going to reach some form of limit? Unless that's your account limit, I guess. But, there's no real like there's no, I guess, real practical hardware limit when it comes to cloud computing just because these cloud providers have such a massive infrastructure. I don't think you'll ever hit, the limit of AWS, the limit of Linode, the limit of Heroku. To the consumer, it is essentially limitless. Any more questions? Well, if you want to learn more about cloud, come talk to me. Also go to Ops Interest Group, learn about cloud there, and then join our cloud team on Ops program. Sorry, I'm like shilling hard today, okay? I'm just in a shilling mood. Cool? All right, boom, we're done. That's a wrap. We run it.